Okay, the third dimension. Let's get to it. Let's go to the parallel viewport, which, as you recall from our tile or our cascade or whatever of our four tiles, that was the 3D one. So if I click on the parallel, go ahead and jump to it, then we can see that we're now in 3 dimensions. Cool. So the first thing I'm going to do, and I don't have to do this, but things are getting a little bit cluttered, so I'm going to go ahead and I'm going to turn off that default layer with all of this black line work that I was doing. So I can't turn it off right now because that's the active layer. So I'm going to turn on the switch to the red layer and make that my new active layer and turn that off. Now what I'm going to do is, so I've got this stuff kind of floating out in space, and that's really all right, but I don't really want that because I just don't like the way that it looks. It also can make the camera behave a little bit funny, and we'll talk about that in a little bit. But first thing I'm going to do is I'm just going to move this kind of closer to the origin, and I can just select it, and I can move it, and then if I did everything right, then it didn't float away, and I did. But the other thing that I can do, which is really helpful, is I can just grab this, use move, say move from there to 0, 0. Sorry, I can't type in public, guys. And that'll move it right to the origin. Now that's really handy if you've got something floating way off in space, or if your camera starts being a little bit of a jerk. Now, let's talk about that for a second because that comes up a lot. So in Rhino, the thing that controls the way that you're looking at things is just called the camera. The way that it sometimes misbehaves is that if you get something and you change, this happens a lot when you change the scale or if you have a really big file, then you might find that it becomes very difficult to zoom in on something all the way. Now, I'm not having that problem because my file is very well behaved right now. But sometimes this happens where you go and you are zooming in and out and you're panning and you're rotating stuff. And by the way, if I hold down the shift button and the right mouse button also, I can just pan this way, which is really handy. It's kind of the equivalent of using the space bar in an Adobe software. So that's really great. But sometimes when you do that, it starts to, the more you zoom in and out and pan and rotate, the more the camera starts to kind of drift a little bit. So the best thing that you can do if the camera starts misbehaving is to reset it by using the zoom select command. So what I'm going to do is, let's say that I'm going to be working on this area of squares, then I can reset the camera by highlighting them and using the shortcut ZS, enter. And what that does is that not only zooms into the space that I'm working in, but it changes the lens length and the camera aim so that it makes my stuff rotate about the center of the stuff that I'm working on, which is really handy. The other thing that can happen sometimes is that it can be helpful to switch from perspective to parallel projection in your 3D viewport. So what does that mean? Normally, when you open up Rhino, the default display mode is perspective, which is what it sounds like. And y'all have done some perspective drawings in your lives as students, so you probably recognize this terminology. But you can see here, off in the corner of the screen, I've got some kind of vanishing point somewhere off, and all of these lines are starting to tilt towards it, and that's all well and good. And that can make for pretty realistic representations if you're using Rhino to model a building, and that's great. But it can also make your computer run a little bit slowly. Sometimes it introduces errors and it makes it harder to zoom in all the way. Actually, it's doing it right now. Now that I've reset it a couple of times, it's confused. So this is great. So this is a primo example of why this kind of stinks. Or it doesn't stink, but it's a problem, and here's how you can fix it. So I want to zoom in more on this corner, and I'm scrolling and scrolling and scrolling, and I just can't zoom anymore. Well, that's fine, because all I need to do, once I zoom out a little bit, there we go, is I can take this and I can switch this viewport to parallel, right? And now I can zoom to my heart's content. And if I switch back to perspective, sometimes the problem is just magically fixed. This time it's not. That's okay. I can drag, zoom selected, and the problem is fixed. Great. Cool. I'm glad that happened because it comes up a lot and it's an easy problem to solve, but it's also, if you don't know how to solve it, it can be a real stumper and very inconvenient. So I'm just going to work in parallel for this exercise, which is how I usually work anyway, because your computer just kind of runs faster. Cool. So we've got some boxes. Now let's make them into rectangular prisms. So the way that I'm going to do that is, well, the first thing is I'm going to start with a curve, and I'm going to make that curve a solid thing. And the command for that is extrude curve, which is extrude CRV. I'm going to select this curve to extrude. Done. Hey, look, it's solid. Now it's solid because I have this solid option checked. The default option on some, in a lot of Rhino settings is to have it unchecked. So if you have it and it's hollow, then first of all, check to see if that box is clicked if you want it to be solid, and then you can extrude it. Now it's just giving me some arbitrary length based on where my mouse is. I can also enter a fixed length, which is what you'll probably want to do. So if I want this box to be 20 inches tall, 20, done. Cool, now I've got a 20-inch tall box. Great. So if you're wondering whether or not there's more than one way to make a box in Rhino, well, there absolutely is. There's about 1 million ways to make a box in Rhino. There's about 1 million ways to do everything in Rhino. So I'm going to show you some more. So we just looked at the extrude curve command, right? Right. So what you can also do is extrude a surface. So what I can do is see these curves, how they're all joined together? Well, that's a closed curve. And I know that because, well, they're all touching, but also because my property panel tells me that this is a closed curve. With a closed curve, I can make a closed object. Or I can make a plane. So planar, the command for this is planar surface, planar srf. There's actually plenty of more ways to make a plane too. And what that's going to do is that will turn that flat collection of curves into a surface, which I can then extrude using the command extrude surface, which is extrude srf, right? So I've got that surface selected, and now I can extrude that as well. I can extrude it. Let's make that 15. So if I say 15, then the direction by default is kind of the positive direction, which is, if I look at my little reference coordinates down there, then I can see that the positive z is that direction. So by default, that 15 is going to go that way. I can also tell it to go down by using my mouse to simply suggest another direction, or I can say negative 15 and it'll do that. Sure, great. So that's another box that I made using the extrude surface command. What if I don't have a surface yet? Well, that's okay too. What I can do is maybe I've got a, what if I explode this and I just have a loose collection of random lines. Well, they're not random, but we know where they came from. So I've got a collection of lines and I want to make a surface from them. Well, that's great. What I can do is I can delete them. I don't even want them. What I can do is I can take that line, I can use that little dot, drag that, make that a plane, or if I want to be more controlled about it, click that, say, I don't know, maybe that's 10. So now I've got a 10-inch long plane, and then I can drag it up by this, and that does the same thing. So that's another way that I can make a box. And if I want to be controlled about that, again, click on it, 10. Cool, that's another way to make a box. So 3 ways to make a box. Maybe my box doesn't want to be solid. Now, let's talk about solids. Stuff in Rhino isn't really solid. It's just enclosed. Because if what I can do is if I use Control Shift and I click this one surface, now when I say use Control Shift, I want to talk about that for a second. If I select this object, it's going to select the whole thing. If I want to just take one of these surfaces off and remove it, there's an easy way to do it. I can either click the object, explode it. Now you can see I've got all of these different surfaces. If I click on this one, I can pull that off, and then I can click on the object again using a shift, look down into the box, click the last one, join it. My box is now back intact, except for the surface that I wanted to remove. Well, that's pretty easy. Or I can do it an even easier way, where if I go back and I undid my explode down there, then I can Control, Shift, click, and now I can select just the surface of an object. So let's talk about that one more time. If I click on the thing, the whole object is selected. If I Control Shift a thing, then just the part of the object is selected, which I can now delete. And I can look inside and see that what Rhino actually does is it makes hollow stuff that it registers as closed or not. So that's an important thing to remember when you're doing Boolean and splitting operations later, and we'll talk about that in another tutorial because we're not there quite yet. So what if I want to make a box that's quote unquote hollow. So many of the stuff that the objects that you're going to be analyzing, I mean, they're not truly a zero thickness object, right? So if I took this thing and I extruded this curve, extrude curve, and I said I don't want it solid, then what it's going to do is it's going to make it just kind of this, this infinitely thin shell. But what if I don't want that? Maybe I want it to have like a little bit of thickness to it. Then what can I do? Well, it's actually really easy. What I can do is I can take this curve and you can use the command offset, and maybe I want to say, I don't know, maybe I want to make a box that's an inch thick, so I can enter that as my distance. And then what I need to do is in Rhino, I need to use my mouse to tell it which direction to offset it. So maybe I want it on the inside. And now I can just grab both curves, say extrude curve, and then I can tell it I want it to be solid, please. And there you go. Now I've got a quote unquote hollow box. Great. Now, there's of course plenty more to design in Rhino and in life than boxes. So, this command works with way more than just boxes. So these are all just curves, right? All these squares. I can draw a curve that looks like kind of whatever, right? So if I go back to the top plane, because I think it's easier to draw on the top plane, and I make, let's do a curve. And that it kind of looks just like whatever. And I'm going to close it. And I'm going to go back to my viewport here. And I click this curve, and I use that same command, extrude curve, which I made myself a shortcut. It's just EC. There you go. Then there's that thing. So you can also see where if I did, something like a circle, or a circle with another circle inside of it, and I select both of them, how I can start to make all of these shapes. Now, the thing that these shapes have in common is that these are all extrusion operations, which means that their profiles do not change as they get longer. They also don't change direction as they get longer, but there are plenty more operations for that too that we'll look at here in a minute. But first, before we do that, let's talk about what happens. Actually, you know what? Let's do that now. So when I extrude things, a couple of things don't change, right? I start with a profile and I have a direction, and the only thing that happens is that that profile basically gets moved along that direction, and neither the profile nor the direction change. But that's not how a lot of things are actually made. So what I'm going to do is, what if I want to start with one profile and end with another profile? Well, I'm going to use a more complicated command that's a lot like extrude, but it gives me a little bit more flexibility with the contours. So the way that I can do this is using a command called loft. So what I'm going to do is I'm going to start with a contour that's, my bottom contour, and then maybe I'll take this and move it up a little bit. And if I open up my other viewports, you can start to see why we have all these options here. Maybe what I want to do is get these more or less on top of each other, right? So, it's not going to be really helpful right now, but this one will be. So I know that if I select this curve, right, you can see in my viewport down there, it's there. And I want to move it so that it is up there. And I can go from the top. Maybe I want to make it a little bit smaller. Select both of these. I can see they're more or less on top of each other, both from the right and from the front, and in parallel and on top. So I'd say those are about where I want them to be. So what this is going to end up looking like is some kind of like truncated pyramid thing, right? Where I've got this bottom that's a little bit bigger than the top, and it's going to fade into this thing. So the way I'm going to do that is using the command loft, right? We can see how these two curves are in space. This one is my first profile. This is my second profile. If I say done, then it's going to ask me where I want this seam to be. In general, you want them to be as aligned as possible, right? So I'm starting both of these on the same corner. That's going to look good. Done. So this is a little bit more complicated geometry, right? This is hollow. I can ask Rhino to go ahead and close it for me, or I can use the command cap, C-A-P, and it'll go ahead and close this for me. So if I click on this, I can see it's a closed solid poly surface, which is usually what I want to work with in Rhino. So loft is a great command if I want a shape where basically the base is different from the top, but what it doesn't give me a lot of control over is what happens in between. So if we recall how an extrude works, it's kind of, you start with a surface there, right? And it kind of moves it along a line, which is parallel or perpendicular to that surface, and then it stops at a given point, right? Loft kind of does the same thing, where it takes two shapes and it moves one into the other along a path that Rhino determines itself. But if I want to determine the path, then I can use a command called sweep. And I'll show you how that works now. So let's say but first what I need to do is I need to define that path. So I'm going to take this line and I'm going to drop it at this corner on this curve here, because this is the curve that I'm going to use to demonstrate this command. And I'm going to, this is a good time to open up all my other viewports so that I can see what I'm doing a little bit better. Because as I draw in the parallel viewport, it gets a little bit hard to tell where I am in space, which is why having some of these other viewports is actually pretty handy, right? So if I start from that curve and I go up here a little bit, right? And maybe I want to come over some, that's fine. So now I've got a little bit of a strange direction here, and I wanted something that kind of felt a little bit arbitrary, and this is getting close, but maybe I'll move this point just a little bit in space so that it's a little bit weirder. That looks good to me. So now I'm going to run the command sweep1, and I'm going to use sweep1 because I only have one rail that controls the direction, and I'll show you what I mean by that. So if I say sweep1 and I select, it's going to ask me to select a rail, and I can say here's my rail, and it's going to ask me for a shape. Here's my shape. I can have more than one, but we're going to start with one for now. And I'm going to say, yeah, that's good enough guess. Done. Cool. So you can see now this is different than an extrude because I have control over the direction. Now, what it did was, since I just had one curve as a profile, it just took that one curve and it moved it along this line. What I can also do is, like a loft, I can choose a different ending profile. So for the sake of consistency, let's just take this curve that I already drew, copy, paste, move from this point to this point. You can see if I spin this around, that's going to be at the top of the curve. And remember, this shape here is smaller than this one, because that's why we got this kind of truncated pyramid shape. So now if I use the sweep command, sweep1, and I select this as my rail, and this is my bottom shape, and this is my top shape, then what it's going to do is, not only do I have control over the direction here, but it also is going to try to blend them together, which is pretty cool. Now, as you can see, something strange happened here as it tried to rectify this curve. So sometimes you might have to experiment with different commands, and you might find that it's better at guessing it at it with a loft. This one, except it didn't. So the way that I can fix this, which is a happy accident, Control Z, loft, U, okay. And you can see what happened here is the way that it drew this curve, it kind of guessed wrong. So what I need to do is move that arrow over there. And I also need to flip it. Flip this guy. Now that those arrows are lined up into a nice tidy seam, it'll zip it up nicely. So the other thing that I can do if my sweep fails, I can try a loft like I just showed you, or I can change the way that my sweep worked. So what I did was I said that I had one rail and two shapes, right? For my sweep, I did a sweep1. I say that's my one rail, that's my bottom shape, that's my top shape. Well, I can reimagine it as something completely different, where I have two rails and one shape, rather than one rail and two shapes. And so the way that that's going to work is, instead of trying to drag this shape into this shape along this rail, I can use a command called sweep2 and say, here's one rail, here's another rail, drag that shape around it, done. And this is going to zip it right up, and there are no errors there. Now, sweep to is a very underused command. I think that it is anecdotally based on how few people that I talk to know about it. I think it is probably maybe the best command in Rhino because it fixes pretty much every single question that I get that's like, how do I make this thing have a top on it, or how do I close this shape? It can almost always be solved by sweep to, I find, if you just use it creatively. So sweep to is an extremely valuable tool. And of course, if I want to just close that off, because both the top and the bottom are flat, I can simply run the cap command, and that'll go ahead and close that shape. Now, the cap command really only works if both of the ends are flat and are planar. Now, that's not going to happen all the time. So if I were to do something like make this shape in a different way, or maybe I took this point and I kind of bent it upwards like this, and I ran my sweep to command, and I said, here's a rail, there's a rail, zip it up with this, please, thank you very much. You can see this is going to be a little bit of a weird different shape, right? Where I've got this, not only do I have a weird angle and a top that's different from the bottom, but now the top isn't even flat. So I bet if I try to cap it, it's not going to work. And it doesn't, because it's going to say one side didn't work. So it capped the bottom because it's flat, but it couldn't figure out what to do with the top. So this is kind of a hard shape to figure out what to do with, but it's not a hard shape to use sweep to on to zip it up. So sweep to, you can just select the edge. It's going to ask for some shapes. How about the edge? How about the other edge? And now Rhino figured it out. So that is a really handy use for this command that gets very underused. Great. So let's talk about one more command real quick for making solid objects, and that command is revolve, and that will let you make another kind of shape that you can't really represent or make in any other way. So let's think about how this works. I'm going to go back to the top plane, right? I'm going to go ahead and I can change my viewport to shaded if I want. Doesn't really matter. And then what I can do is on this top plane, I'm going to draw a shape that I'm going to revolve around an axis. And you can see, and I'll show you why this is useful if you can't imagine it already. So let's say I'm going to go ahead and do something like, I don't know, maybe what I'll do is I'll start here, draw a straight line, and then maybe what I'll do also is, I don't know, let's draw a nice little curve here. Maybe I want to make kind of a spoony shape. Let's rebuild it so there are maybe a few fewer points. There we go. That looks kind of nice. Cool. So that's a little bit of a spoony thing. I think I still probably a little too farther out there than I want it to be for this demo. Then let's take these. Maybe I want to add a little bit of a fillet to this guy here to give it a little more roundness. Maybe I want the radius to be like 1. There you go. Let's join all this stuff. And then, because I want this to have a thickness to it, what I can do is, actually, let's just do it simply first. Cool. So what I'm going to do is I'm going to say, I want this to revolve. And it's going to ask me to pick an axis, right? So I could draw it if I want to, or I can pick a point that already exists as reference. So I'm going to draw this, and it's going to ask me the start angle, which I'm going to assume to be 0, which is going to be the location of this curve in space. And if I take a look at this in 3D, it's going to be a little bit easier. So if I say start, it's going to start where this yellow line is. I could also offset this at like 30 degrees, and it's going to start somewhere else. But I'm fine with it starting on the line. Okay? Then, when I hit enter, it's going to ask for the revolution angle, right? And I can either draw this with my mouse, or I can just tell it that I want it to revolve. I don't know, what's an easy number? 180 degrees? Half a thing? Done. So you can see this is how I can make a shape that I wouldn't really be able to make with any of those other operations. Now I can also make completely normal shapes like a cone or a tapered thing. You can imagine where I could make this same shape by revolving a little thing that looks basically like, well, here we'll do it right now. Because I'm basically revolving a square. Draw an axis. Done. Right? If I had done it 360 degrees instead of 180, I would have gotten this same shape. Now, where I draw my axis is going to be the thing that influences how far apart this is. So the best way to do this when you're doing something like a revolve, if I do it again, is to go ahead and plan for that, right? So if I do something like go ahead and draw a polyline, maybe I just want to offset it. Maybe I want to say, or how about this? How about I draw a polyline? Let's turn off that annoying center snap. From there to there, the length of the axis is arbitrary. And if I know that I want that inner hole to be an inch wide, then what I need to do is move that in that direction, or that direction, that's fine too, by 0.5 inches, right? Actually, that moves it to the inside, so we're going to undo that. Negative 0.5 inches. So because I want that inner circle to be hollow, then I need to make sure that I'm giving that radius a half an inch of offset, right? So, and that's going to be giving me a 1 inch hole. So if I say revolve, and I use that as a reference thing for my axis, and I just hit enter a couple times and use the default settings that I had last time, then what I can see, if I go back to my view, is that I've got a circle with a 1 inch internal diameter hole. And I can do that by measuring it with D, distance, bloop, 1 inch. Because again, I offset this by half an inch and then revolved it all the way around. So I've got half an inch on that side, half an inch on that side, and that's how you plan for an axis of revolution. Now, if I need to move stuff around in 3D, it's a lot like moving around in 2D, except for you can do more things, and there are a few little exceptions. What I can do is, just like in 2D, I can use the gumball to move this a controlled length, so maybe, I don't know, a foot. That looks good to me. Or I can use the move command and pick a reference point and say, I want to move this a foot. And this will constrain all my movements to a foot in any direction. If I'm having a hard time trying to tell in 3D where I'm actually moving it, then again, open up your top views and you can use any of them to help you plan the motion of this, right? So you can see here, as I move this around in the top view, I can get a sense in the other views of where I'm actually moving. So what I'm doing is, even though in the top view it looks like I'm moving in 3D, I can see from my front and right view that really I'm just moving it around the top plane. So if I actually wanted to move this up a foot, the easiest way to do it, I think, just to hop down here in the top plane, you can see I'm actually moving up. You can even use shift to lock that direction in. Bam, there we go, I've moved up a foot. The other thing that I can do is I can use the move button to accomplish the same command, or I can use another preferred method and use objects as reference points. So let's say that I wanted to move this box from where it is now, here kind of at the bottom level with this other thing, to where it is in the same spot, except for it's moved vertically and level with the top of this box. No problem. I'm just going to use that box as a reference tool, and I don't need to know how tall it is. So I could just like figure out how tall that box was and say, all right, Rhino, move it, whatever that number of inches is. Or I can just click it, use the move command, say I want to move it from here to here, and there you go. It's moved it that distance by using those two reference objects. Now, what if my thing isn't straight? What if I wanted to do something like move it from where it is now to whatever the height of the top of this thing is, but keep the motion constrained vertically, right? So I want to move it, again, from that height to that height, but I don't want to actually move it in any other direction. So let me explain one more time. So if I move it using this as a reference object and I say, all right, here's my start point, here's my end point, then what happens if I do that is not only do I get the right height, sure, but I'm also moving in the direction that corresponded to the location of this versus the location of that. So there's a built-in little thing to make that easier because you can move stuff vertically. If you're building like something like a building, for example, in Rhino, and you want to move stuff from one floor to the other floor and you don't have an easy reference point, except for the fact that the floors are different heights, this is really handy. So if I can click on this object and I can use the move command and I can say, I want you to keep it vertical, then what happens is when I click those two reference points, you can see that even though I'm moving laterally, the object itself is only moving vertically, which is really handy. Now, of course, I can also move things very simply by simply clicking on one location as a start location and another location as a finish location, which is pretty handy. The things that I can select, again, just like in the 2D world, I use my snaps to control what I want to be selectable. So for example, if I wanted to move this cylinder so that it was concentric with this hollow cylinder, then the easiest way to do it is to simply click the center of this and move it to the center of that. And the way I need to do that is I'm not going to be able to do it unless I have my center command selected, right? So you see it doesn't give me the option to actually select the center, but if I come down here, click it, now I can select the center of here, and then if I hover over this, it gives me the option to select the center of that object, and there it is. If I want to move it again, then maybe I want to move it to the top. So if I select vertical, there we go. Now I've moved it the length of this thing without even changing its direction. That's a really handy way to move stuff. Well, the move command is really great and it's really useful, but it's also kind of crude. It just moves stuff from, it kind of just shuffles stuff around. It doesn't give you the ability to kind of rotate or align anything. And if your stuff isn't actually rotated or aligned, then move is only but so helpful. So for example, if I take this box and I rotate it, right? And I want to move it so that it's up against this box, move is not helpful. Not really anyway. What I can do is I can move it here and then put it up against here, and that's fine, but the rotation is still, it's still off. So I can fix it by using the rotate command, just like in 2D. Rotate, it's going to ask for a center of rotation. By default, so here's the thing, if you use the gumball for this, it's always going to rotate about the center. In order to get this to rotate so that it meets flush with this, you need to put the ends together, and then for your center of rotation, make that the pivot point. So I'm going to select that. Make the first reference point somewhere along that edge, right? You can even use the end. And then move it so that it snaps to that edge. Now I can't really see that edge very well, so I can go down here, select it from another angle, or I can change my view from shaded to ghosted. I can see through this box a little bit to this, from this curve to that curve, which is very handy. So move plus rotate is a useful duo of commands, but there's one that has that built into it, and we talked about it a little bit in the 2D version of this tutorial, which is Orient. So if I take this guy, I move it, and I put it somewhere a little bit less convenient, right? Now what I can do is I can move I can combine those steps into one step and use the Orient command just like I did with the curve in the earlier tutorial. So if I click on this and I say Orient, then it's going to ask for reference points on this object, right? Which I'm going to say, maybe let's say that corner and that corner. And I'm going to align it with reference objects on this object, maybe that corner, and that corner. And there we go. Now they're lined up and moved in one step. Orient is also the command that you want to use if your thing is really inconvenient. So let's say it's messed up in a couple of different directions, right? So what you can do here is use the command Orient 3D and fix it. So if I click on it, Orient 3D, sorry, it's actually Orient 3 points. Then it's going to ask me for a first reference point, a second reference point, and a third reference point on my moving object. And then maybe I want to give it a first reference point, second reference point, third reference point on that object. And I guess pretty close. I'm a little bit off. So what I can do now is just move it vertically from here to here. And now I'm all lined up again. And just like in 2D, the 3D resizing commands work the same, or work very similarly. So if I use scale, I can change the scale of any of these objects. Scale automatically will scale it in 3 directions. If I just hit enter, it will scale it about a centroid. And if I want to make this box twice as big, I can just say 2. Now it's twice as big. Done. But if I want to be smarter about it, then I'm going to use scale in a different way. So if I want this box to be scaled in all directions and also be the same height as this, I'm going to use scale, and I'll say I want to make the base point here, which is going to be the stationary point. I'm going to make the first reference point here, and I'm going to say, okay, well, just scale it so that they're the same height. So I'm going to drag it up here, and now they're the same height. Now, you'll notice that it also grew in every other direction. That's normal, because that's what this version of the scale command does. If I just wanted to increase the height, then I can use the command scale 1D. Select the base point, select the first reference point, tell it where I want it to end. Done. A lot about how to make stuff and about how to move stuff. Everything that we've made so far, though, with the exception of the hollow areas in the revolve and the extrude commands, were solids. So let's take a second to talk about voids. So what I can do is I can either design a void into the thing that I make in the way that I did it here by extruding a circle with another circle inside of it, and that which gave me a hollow space, or here by revolving this in a way where I revolved a hollow space into it. Now this I did as a surface, so what I would probably do if I were doing this project for real is give that curve that I revolved, actually I'll do it right now, offset it, let's do it real sloppily real quick. I accidentally made 2 of those. You and you. Close that. You and you. Close that. So I've got 2 of these curves in the same place. I'll delete it. Now what I'll do is I will join all these. So now that it's a closed curve, if I revolve this around some axis, then what you can see I've done here is I've kind of built a void into this. If I've made kind of a solid, especially if I cap it, there we go. Now I've got a solid with a void built into it. So that's another way that I've planned for a void in the way that I've designed the object. But sometimes you can't really plan for the void. You need to subtract a void out of something. So the way that you can easily do that is by using a command called Boolean difference. So you need closed poly surfaces for this. So what I can do here is if I need, let's say that I have this solid, let's pick a box. Here's a box. I'll move it out of the way so we can see better. And I want to make a void that's shaped like this thing in this box. Well, let's do it. So the key here is that this box is a solid poly surface, or a closed extrusion, which will also work. It's a closed object, which I can tell from the object type. This one is also a closed extrusion. Solid poly surface will work as well. I'm going to rotate it. I'm going to move this so it intersects with this thing. Now if I use the command Boolean difference, I can subtract from this with this. But there you go. There's a void. So while we're at it, let's talk about another way to make a void. So if I don't have two poly surfaces, which might happen if I have something like maybe I've got, just a surface that I want to use to cut a shape in another shape, or maybe I have like a, a long flat sheet shaped something and I want to use that to chop the top off of something, then I can use a similar command called Boolean Split rather than Boolean difference. So what I can do here is let's go ahead and let's just make just a surface. Extrude curve. And let's not make it solid. Let's make it hollow this time so we can see what's going on here, right? So if I take this, make a handy little cutting tool, drive it through that box, and I use the command Boolean split, then what I can do is I can split this thing with this thing. And the way that that's going to look is it's not going to look very different. But you can see it's left a mark here. And the reason that it looks like this is because, again, like I said earlier, everything in Rhino is hollow. So what I can do here is I can grab this surface, pop it out, and what it's done is it's gone ahead and it's made a closed surface inside of that hole. Now, the difference here between Boolean split and a regular split is that in a Boolean split, it will go ahead and it will close that area up for you and will make sure that this thing still looks like a solid thing. If I just use something like a regular split, which I'm going to do here in this way, and I say split with this, and then I move this out of the way, and I delete the plug, you'll see that this is hollow now, which is not what I want. What I want was for my thing to just have look like it had a hole drilled in it. So this is why it's important to remember that everything in Rhino is actually hollow, and you need to make sure that you're taking steps to create closed geometries when you punch holes and stuff. So as long as we're on the subject of solids and voids and closed curves and open curves and Booleans and all that stuff, I want to take a moment to talk about a very common technical error that happens in Rhino, which is not really Rhino's fault, but that will hopefully, now that you know how to look for it, save you a lot of time in trying to make solids solid. So if you have this nice tidy closed curve that we drew earlier, and let's break it up a little bit, explode, so you actually end up with 4 unjoined lines, and you try to make this a solid extrusion. Well, Rhino is getting smarter and smarter with every release, and usually it can figure it out. So if I select all 4 of those curves and I say extrude curve, and I have this solid option selected, then you can see that it's actually figured it out, and it'll make me a solid box just fine. But not always. So here's what happens a lot, right? It knows how to make sense of these curves that are all touching and not overlapping, because it just knows how to do it. Somebody taught it well. But what happens sometimes, maybe I've copied and pasted this thing by accident and forgotten about it, where I've got 2 curves in the same place. And maybe it happened over here too. Or maybe I've got one that I kind of started to draw and then I forgot about it, and I don't know, whatever. And then I came over here and I tried to do that same thing where I grab all my curves and extrude them. And I want that, and I want a box. And even though I have the solid option selected, Rhino does not know what to do with all that stuff. So if you think you're trying to extrude something that's solid and you're not getting a solid, well then the first thing you should look for is stuff that's overlapping, because that is almost guaranteed to be the problem. Now you can test this pretty easily by clicking around on the object and looking for how many extrusions there are. Because if you've got a whole bunch of extrusions in one place, that means you had a whole bunch of curves in one place, and Rhino just extruded all of them. So if I undo that, then what I can do is I can go back and start to dissect my messed up object. So the first thing that I might try to do is just join them and see what I get. And I know right off the bat that I've got a problem because it tells me that seven curves have been joined into one closed curve and two open curves. So if I select it again, Rhino might be able to figure this out. Extrude curve. It did. So sometimes you can just join it and it'll work. But you still got a whole bunch of excess line work. And if that doesn't work, then the best thing that you can do is click around and you can do something like cell open curve, and it'll show you where your open curves are. So that is a good guess that one of those might be messing up your stuff. So you can click around. If you've got a redundant curve, maybe you want to delete it. Or if I undo those deletes, what I can also do is go to edit, and sometimes this works. Edit, and I can go to select objects, duplicate objects, and it will look for anything that's I've got more than one of in one place. Now I think it actually didn't work this time. So sometimes it doesn't work. Good to know. So clicking around on these objects, I can delete this. I can delete that open curve. Sometimes though, what you might have is a curve that's on top of another curve, and it's hard to tell where it starts and ends. So if I click this, and I think that looks fine, but then I've got this curve here, and it's kind of hard to that's easy to see where that starts and ends. But what I might end up with actually is something like that, where it's really hard to tell if you've got a closed curve or an open curve because it overlaps. So one thing to look for if you're trying to diagnose open curves is weird points along a line that aren't at a corner. You can also use a command like, if I select my open curve, which I know I'm doing because it'll tell me this is open curve, I can use the command called curve start. And what that'll do is drop a point on the curve where the start point is. I can also select that same curve, the open curve, and use curve end, and it'll mark the end point. And if they're not in the same spot, then I know that's probably that weird open curve that I've got. Then I can just delete that point. So that's one way to diagnose failing extrusions. Actually, there's a couple ways to diagnose failing extrusions. Okay, and that's it for now, at least. That is all I can think of for this Rhino tutorial, but I'm sure there will be plenty more where that came from later. Good luck.